We'll be talking about moving and converting table partitions. Why is this important? The table partitioning is a new feature in IRIS SQL, which we've added in version 2026.1 as an experimental feature. It allows a lot of the improvement on the scalability, performance, and ease of use of the large data. We'll start with the brief recap of what the table partitioning is. When it may be helpful, we look at the architecture, we'll look at some details of the implementation, and then we'll focus our attention of the converting and moving the partitions of the table. We'll do the like demo, obviously. So, why the table partitioning? First of all, everybody has a problem with the large tables. It could be audit tables, it could be the telemetry tables, it could be any source of data which is huge. It does not only make the query run slow, it will all the operations with the table run slower. Your backups, your integrity checks, your bulk inserts, bulk updates will be slow and expensive. There's obviously a financial impact of storing all the data in one place. You are mixing your old, rarely used data with your new, recent, quite often used data, but you are paying the same price for your hard storage. Also, the table level locks or locking in general during the transaction becomes a problem. If you have to update 1 million records in a 10 billion records table, you either have to take 1 million individual locks on each record, or you have to take the one global table lock, which will either slow down or serialize your transactions. That will severely degrade the performance of ingest. The solution? Yes, let's split the table into buckets in a horizontal way. We'll add the partitions key for the logical meaning. We'll provide automatic storage mapping per partition. We'll take advantage of the locking made on the bucket level. We run everything in parallel based on the buckets. And of course, we'll provide the simple SQL DDL. Here's just an example of multiple storage tiers which you can use to store your cold, old, archived data and on a cheaper storage, and you can store your hot, most recent data in a local SSD or non-volatile memory. How did we do it? First of all, if you look at the slide, on the left you'll see the logical division of your table into partitions. In my example, I partitioned the table by the quarter of the year, and each quarter has its own logical partition. Physically, we store it, as shown on the right side of the slide, in the buckets. So each partition may have arbitrary number of buckets. Buckets are usually very large. Think about from 1 million to like 32 millions of records each, and they are self-contained. So the storage mapping, locking, and running in parallel is executed on the physical data unit level. We provide multiple types of partitions, for example, range, list, or hash. Range may be applicable to either numeric or date or timestamp data types. A list is best suitable for the fields where cardinality is low. So if you have the categorical value, that's a candidate for the list partition. If you don't care about the partition key values, but you just want to spread your data in a horizontal way, you may use the hash partition and break your table in a fixed number of partitions. How we do it under the hood? We are using globals with the extra subscripts. So if you look at the partitions key, the partition ID is the first subscript in the storage of the global of the partition table. The bucket ID is the second. If you use multi-level partitioning, all the partition key will be the leading subscripts. At the bottom of the slide, you can see how we combine the partition ID and the partition unique row ID into one globally unique row ID. Why we are achieving the better performance with partitions? The answer is very simple. We are using the partition pruning. If a query has a condition in the where clause which is targeting the value which we may use to derive the partition key, we will apply this knowledge as a metadata to the plan, to the query execution plan, and it will skip processing the whole partitions if the values there do not match the condition in the query. How do I create a partition table? Very simple. I'm using the standard SQL DDL, which is pretty much English, and I'm just adding the partition clause at the end of my create table statement. Now, a very important question which you may ask. If I already have a huge table, how difficult is it to partition it? It's very easy. The conversion is done by using very simple standard SQL command, alter table, convert, and you specify the partition by whatever type you may think is most suitable. What's happening under the hood? When we start the conversion, we just create the shadow copy, empty at first, and we start moving one bucket at a time. We combine the rows into buckets, we combine them into partitions, we map them appropriately, and we move them into the new table. This whole process is online. Your queries will never stop, your updates will never stop. It's totally transparent to the user. When all data are moved, we disable the original table, the partitioned extent will become primary, and when it's done, the source data will be deleted, and your table will be fully partitioned. Important part, the conversion process preserves the original IDs of the table. The main reason is your table may have indices, your table may be a part of the primary foreign key relations, and it's important to preserve the IDs as they were. For that purpose, we create the surrogate ID and we keep the new real row ID. There are definitely some restrictions. We cannot convert the table which doesn't have the system assigned row ID and does not have the default storage. Shadow tables currently are not supported. We are working on that will be released in the next version. What do I do after I convert? I may want to move my old data to the cheaper storage. Here's an example how we do it. We just move partition, we specify the single partition or a partition range, or in case of multi-level partition, we may specify all the applicable partition keys. What happens under the hood? Very similar story. It's the online process. Everything is transparent. We map the script level mapping of the partition to the target database. We start copying using the data move. When the data move finished, we activate, which means all the reads and writes will switch to the new location. And after this is done, we delete data from the original location. A very simple process. Let's take a look how it executed in live demo. I'm going to create a simple table. It's alerts. It's kind of a result of a telemetry, getting some readings from the sensors. So I've created the table. I am going to load some data. It may take a couple seconds. So I think I'm loading about 100,000 rows. Yes. Let's double check. Let's select count of records from this table. Looks like, yes, it's exactly 100,000 rows. So let's check the range of my data. I'm going to select minimum and maximum timestamp. And yeah, I have data starting in 2023 on the New Year Day, and the last data are marked as April 30th, 2026. Time to convert this table to the partitioned. So I'm starting the conversion process. I'm going to take a look what's happening with my tables. So I used to have just the alerts as a table. Let's quickly look at the tables. Oh, there is an internal table which is called IRIS convert something. I made it visible for now. In real life, you will never see it. But that was what's going on under the hood. My conversion just finished. I'm gonna refresh the information about tables. I have my alerts table fully partitioned now. Let's take a look. I'm looking at partitions, and they all are located in the database TP, and I have the partitions for each month from January 2023 to April 2026. Very good so far. Let's execute some queries against the newly partitioned tables and see how they behave. I'm gonna select some alerts from today going 12 days back, and I want to limit them to value greater than 50. Let's run it. It's really very fast. It's just 5 seconds of a 500ths of a second. So why is it fast? Let's take a look at the plan. I think the answer is right here. The plan utilizes partition pruning. So instead of reading each month of data, we only read a single partition for April of 2026. That's the main reason why this query was that fast. Now, since I have it partitioned, let's move my old data to the slow storage. I've already created a database. I named it slow store, and I'm going to move data from January 2023 to December 2023. I'm gonna run this command, and while it's running, I'm actually gonna look at my table again. Let me refresh, and I'm gonna look at the table, what's going on there. Right now, everything is still in the same location, so it takes about half a minute to run this move partition. When it's done, we'll see that all of the partitions for that year moved to a new location, and it's just happening in front of our eyes. We can see that all partitions for year 2023 now are stored in the slow storage. Let's do kind of opposite thing. We're gonna move the most recent data to the fast storage. So again, I have created the fast store. I'm going to move my data starting from January 2026 till the end of 2026 to the new faster storage. Let's see what's going on. I'm going to refresh my data again and see what's going to happen there. So go into tables, taking a look at my table, partitioned, and if I scroll down, I will see that all my data for 2026 are now stored in my fast disks. You may ask, what would happen if I add more data for the next month? Good question. Let's take a look. What's happening if I insert a single value for now for May of 2026? I'm going to execute that. I'm going to go check my table again. What happened with the partitions? Oh, look. It automatically created a new partition for May of 2026, and it put that single record there. So everything is done automated, totally transparent to the end user. Going back to our presentation, we'll just, in a summary, look at the two operations which we did today. We converted the partition and we moved our partitions. And the slide also describes when we are doing this and what are the advantages of moving and converting the partitions. Thank you very much.